So we were doing it correct, but the reason why we couldn't do it is because of the limitation on the packet tracer. My notes all over the place. Let's see, where did I put it? Anyway, so over here we go to config T IP IPv6 actually IPv6 DHCP, and if you put question mark, um, no, you have to go to the interface. I'm sorry, the interface first. IP config T interface. Let's say gigabit 0/0, and you say IPv6. Question mark. If you did DHCP, question mark. And that's what we're talking about. You see, we say client server. So there's supposed to be another option called relay. Okay. So on the packet tracer, they don't have that. But I was looking at some articles, and whenever you put that question mark, it has a third option, which is not listed in the packet tracer. So I'm gonna email Fort Worth to see what we can do to enable the relay. So what is the main objective of this relay? Is basically to configure the HTTP server on a different LAN than the clients. And we need to have, in order to the client to get an IP address from a different subnet, we need to configure that router with DHCP relay. Okay. So basically that interface or the gateway for that particular LAN, we need to help them to communicate with the DHCP server. So if we put relay here after this command, then we say space, then we put the IP address of the DHCP server next to it. It's the same concept as IPv4 when we say IP helper address space and the IP address of that DHCP server. So I know we're gonna have a test tomorrow. So do you have any question about DHCP version 4 first before we move further? Yes, no, no, yes.
No, sir.
No, sir.
Okay. Now on the IPv6 configuration, it's the same concept. I think we have, I configured this one with IPv6. Let's see. Exit. Exit one more time. Show run. Let's see, no, it doesn't show run. Yeah, this one has the old one with IPv6, IPv4. See that? We did that. Yeah, didn't work with that. Okay. So now we get some issue yesterday on configure a DHCP v6 DHCP v6 server. So what happened if we connect this guy with a multiple PC? Let's see. So now we need to connect it to the same switch right here. Doesn't matter at this point what ports I can connect them to. I just want to see if it works as a DHCP server. And again, if I'm doing it this way, what kind of DHCP server I'm creating? I'm creating basically when there's no router involved. Basically, it's going to be stateful. That means every options, everything is handled by the server. And that's basically what's going to happen. So in order to do this, now also, if you want, you can connect this one to a router, okay? So no big deal. So you will have a partial configuration on this server here. It's like a stateless, if you want to connect stateless, and the router will handle the rest. So if you want to do that, you have to click on this machine. You need to give it an IP address with IPv6, which is already did. If you go to desktop, I gave her this number. Let me write it down because I can forget. Um, so this is going to be 200 or 2000 face cafe. Came up with those names, so it'll be a lot easier. /64. Okay. So the first thing I need to do, I need to go to services. I click on a DHCP6 and need to put that server in there. Then I need to create a pool. Okay. And I need to give it a name for that pool. So I'm going to call that what would you call it? IPv6. I'm going to call it pool. And I need to put, for example, the DNS name, which is, I can put the IP address for the DNS like 2000 colon face colon cafe double colon, and I call the server is 10. I can make it like 9, and also I can put the domain name how about stp.com. I just came up with that. And now you need to put at this point it's stateless. Basically, I'm going to provide everything will be around on the router except with the DNS is pointing to that server. So if you go next, what's going to happen? Okay. Then over here, if I want to use, I need to create another a pool right here to go to stateful instead of stateless. Okay, so I can do that too. Let's see. Let's see. We go right here, and when you do the IPv6 local pool, so I need to create a local pool, I guess. Yeah, the IPv6. Let me go create the local pool first. Let's see, create a local pool. No, I need to create this one first. Okay, this is 200 IPv6. Uh, we call it the 2000, I believe. And this is like a prefix 64. 64. Let's see. I'm not sure which one we need to do first, this one or the other one. Let's see. I'm looking for some documentation. So, enter this one. Okay, that's fine. You go to stateful DSP. You go to yeah. I need to go to local pool. Let's see if I can save this one. Nope, I previous input. Local pool. Yeah, so I have to do local pool first. That's in the local pool. Okay, so local pool is going to be IPv6 and the prefix is 2000, I believe, colon, and the prefix 64. And of course, here is the 64 also. Then you save it. Okay. Now we go over here and create it. And go to let's see why this is a prefix is what's the prefix on that? What was it? 200, 2000, colon, face, colon, CAFE, colon, 64, okay, name, IPv6, save. File cannot be empty. Which one? Oh, the identifier, unique identifier. Let's see what we're supposed to do on the why. Let's see where's the unique identifier. What we're supposed to do. Say what's the GUI 4? Let's see how I did that on the other one. Let's see. Edit. 1064 save. Okay. Let me see if that's gonna work first before I go any further. So if we go to desktop and you go to DHCP, yeah, it's not working. Let's see. Static. Oh, I did that. Let's see. I think I did one of the server right here. One more time. So you go to this one here. We did this one, valid 25, local pool. Can we edit the first one? Okay, so this is DNS. This is the local one. Edit. Save. And this one, what is the problem with this one here? Prefix create. IPv6. Local pool, let's see. IPv6. Did I say it was saved in here? Yeah, that's it. Okay, now let's see. I don't know why it's not. Yeah, now it's working. Now it's working. So I guess it takes time to send the unicast back to it. Now it's working here. So now you can see if it's pinging or not. So we can go to, let's see, this guy here, and you go to command prompt, and you can do IPv6 IPv6 config/all. What? Oh, IPv6. One word. Config/all. There we go. So as you can see, you have the global unicast address, and you have the link local address. So this is the link local address right here. And this is the global unicast address. Notice you have the 686C on both of them. So what that means is, if you look at the MAC address, okay, that's the MAC address right here. So it's part of the address is the MAC address. You see that? So the FEAA, even this part right here is part of, you see that FFE right here, FFE, that's basically part of the MAC address inserted there. So you can see this one, which is part of the MAC address. Anyway, so can we ping this guy from the server? And that's what we need to test. Copy, and we need to go to different address, different machine right here. Command, right click, paste. It's good to put ping in there. Not in there. In the front of it, so ping, PING, enter. Okay, so it looks like it's working. So that's the stateful. That's a stateful configuration. Okay, so everything's handled by that server. Any question about this server? No questions? Any question about the test tomorrow? So for the test tomorrow, you're gonna have, let me see. Well, I forgot to send an invite for one student. Let's see. I don't understand that. Why we have to do that every day? Emails. So any question about the written part or the online test for tomorrow? Participant or invite. Okay. question about the test? No?
Not really.
Okay. If you don't have a question about the DHCP, we can start a new chapter, which is, let's see. Let's see which one is start chapter. Chapter, which one is that? 8? Oh, that's chapter 8. Chapter 9. Chapter 9. By the way, I uploaded the PowerPoints on the files folder. And also, I uploaded some of the smaller one PowerPoint to the folder too. So you should see it here. Any question? Questions? Okay. First top redundancy protocol. This is new technology basically because we create redundancy on the different layer. We create redundancy on the physical layer by adding extra cable or extra leg. We create redundancy on layer 2 with the span tree protocol. But the question is, that doesn't matter how much on each layer you create with redundancy. But what happened if the router 3 failed? At the end of the day, you have a router, and the router is a single point of failure. So what is going to happen in this regard? So if you go to Packet Tracer, basically what I'm talking about is let's see, maybe we can take this one out. Boom, 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 boom. Okay. So what happens if this guy's go down? Okay. So basically, this is connected to one leg. So, as I said, this is the ISP right here, it's connected to the cloud. Let's see, maybe this one is the cloud. Turn it off. Let's add a serial interface to it. Put it back on. Same thing on this guy here, turn it off. Let's add a serial interface, that's cool. So we can create link in here. This is still down.
On the first router.
Oh. Put it in there. Okay. Now. So we connected the serial to serial. Okay. So it doesn't matter how many hosts we have on this LAN here. So the ideal situation is, say, what happened if this one goes down? Somebody said, okay, we create another router. We just put another router in there. Okay. So what's wrong with that picture? Let's see. So if, for example, I have another link right here, does this switch to this router? Okay, so this is going to solve the problem if I put another router. what's wrong with that picture? So every machine over here is going to be configured with what? With a default gateway. So that's basically the case. So you have, for example, 20.1. That's the interface for this. So even if I have a multi-router over here, another router, so if this fails, I'm going to go back to each device and change the what? The default gateway on it, which is a lot of work. Okay. So that's why they come up with the they call it it used to be a different name, but now they have it FHRPs, which is first hop redundancy protocol. Okay, to able to create what we call something called a virtual router or virtual IP, is to call it. Okay, and that's what it's the first hop redundancy protocol mechanism that provides alternative default gateways in the switch network where two or more routers are connected to the same VLANs. Need to see how that works. Now, even if we create, if we have another router over here, right? So somebody said, okay, I can come to this machine, in each machine, whatever, and change the default gateway in it. So even if you change, sometimes it's not going to work as fast as possible, because what is also associated with .1. Remember we talked about ARP, the MAC address table, because whenever this guy wants to communicate to the cloud, okay, so it's going to send ARP request to this default gateway, which is he wants the MAC address for this. The MAC address is going to be stored in the ARP table for a certain period of time. Even if I change the address, the gateway address is still on the MAC address table. So that's another problem. So to resolve all this, okay, that's why they came up with the first hop redundancy protocol called the HRPP. Okay, and the way it's going to work is to create what we call a virtual IP or virtual router. Also, we're going to provide the client with a virtual MAC address. So the client's going to always, regardless, is going to have a virtual IP and a virtual MAC address associated with that. So what does that mean this? So at this point, this router here, router 1 or router 2, each one of them is going to have an IP address. Let's say that one, and this one is going to have that 2, whatever address. Now, or I can have that 2 here, that 3 here, or whatever. It doesn't matter. Now, I'm going to create another virtual router here, which is VIP or virtual router or virtual address, and also I'm going to have a virtual MAC address. Okay, so with the virtual router, what IP address am I going to assign? Maybe I can put .254 or .3. Doesn't matter. So whenever I'm going to use this kind of technology, I'm going to assign these machines with the route, with the right gateway. So I'm going to assign it, for example, 192.168.10.3. No, not that 3. There's not that. Let's say, and the gateway is going to be 192.168.10.3. Somebody said that .3, this router is .1, this router is .2. Where's the .3 came from? That's what the virtual router. So regardless if this link goes down or this link goes down, always I'll be connected to the cloud. Okay. Of course, they have a mechanism or process we have to follow to understand in order to change, because one of these routers has to act as a boss. Okay, and he's in charge. So that's why we call them. One is going to be active. One is going to be what? Passive. One is going to be active. One is going to be on standby. And that's basically how it works. Now, the question: who's going to be active? Who's going to be passive? We have to follow certain rules. I'm going to talk about it in a few seconds. This is they talk about what we talked about earlier on semester 1. For example, one way to prevent a single point of failure at default gateway is to implement virtual router. To implement this type of router redundancy, multiple routers are configured to work together to present the illusion of a single router to the host on the LAN by sharing an IP address and a MAC address. Two or more routers can act as a single virtual router. So it's not just one. I can put more than a a physical router. So that's what we call in the group. We can put up to, I think, with the new technology, we can put up to from, I think, 1024 routers to be in redundancy and load balancing. On the old version, we used to put 255. Now they enhance it to 1024. Can you imagine you can put like 1024 redundancy in layer 3? That's a lot. And usually if you want to do this kind of technology, you're not going to mismatch those routers. You can put like Cisco or whatever. But it doesn't matter because this is standard. So you can implement that technology. So there always is a correlation between if I said, okay, I'm going to create virtual P, but somebody said, okay, how about the MAC address? Because we always associated, because whenever this guy recognizes that the destination is on a different LAN or a different subnet, he's going to request the MAC address for the gateway. So that's why we always also need to work with virtual MAC address. So anytime we have a default gateway, we need also the default MAC address, or the MAC address for that default gateway. Let's see. So redundancy protocol provide a mechanism for determine which router should take the active role in forwarding traffic. It's also determined when the forwarding role must be taken over by a standby router. The transition from one forwarding router to another is transparent to the end devices. So the ability of a network dynamically recover from failure of device acting as default gateway, known as the first hop redundancy. So what does that mean? It means I have more than 2 routers to create a redundancy. And we know each router is connected to the same LAN. Well, the way you connected to the LAN with the interface, that means this interface and this interface are on the same network as this guy, as the client. So, because I'm not going to change every second the default gateway on this one, I'm going to assign the gateway for all these devices, end devices, with the virtual IP, which is, for example, if this network, what network is this? Let's see, 50, 20. I made a boo-boo. This is .20, not 10. Same thing in here. So now this is virtual. This is the virtual router. But if, for example, I'm on PC 7 and I'm trying to connect to the cloud, which path I'm going to take to the cloud? Of course, over here you might have another connection in the cloud right here. Okay. So, or I'm going to go this way, or I'm going to go this way. So, how are we going to determine that? And to determine that, are we going this way? Or I'm going to go that way. Okay. So, how are we going to make the decision? To make a decision, if I am using this technology right here, the first hop, the first hop redundancy protocol. So I want to make decision if I'm going that way. If I'm going that way, means this guy's in charge. If I'm going this way, means this guy's in charge. So how we know which one is going to be in charge? Now, from user perspective, he cares less which one is going to be active, which one is going to be standby. Or all what this guy cares about is to have continuous connection to the cloud, to the internet. So, and that's why we have to go through the process. As you can see over here, we need to configure each router, the physical router, not the virtual, because we have the virtual router right here. This is virtual, y'all. It's not really a physical connection, okay? It's just virtual. Assume, believe that this is a router over here. But in reality and physically, there's no router in here. It's a virtual router. So we're going to configure this router by something called standby, and this one standby. So one of these router here and here, basically the physical router, need to be active. One is going to be standby. So the one is going to be active. Basically, once we configure the standby on both of them, the standby is going to decide which router is going to be the active and which one is going to be the standby. So both routers, by default, they have something called priority. So whenever they exchange standby message, they exchange the priority. By default, the priority is 100. So if both routers by default is 100, so at this time we cannot decide which one is going to be active, which one is going to be standby. Now, to break the tie, we're going to say, okay, the router with the highest IP address is going to be the active one, and the one with lowest IP address is going to be the standby. So according to this, what I'm saying, this is has .1, this has .2. Both router has the same priority. Therefore, this is going to win because it has the highest IP address. So in this case, this is going to be the active one, and this is going to be the standby. Now, the minute this guy goes down or this link goes down, automatically the user is going to go through this router right here. You follow the idea? Any question about this particular topic? So that's the big picture. Of course, there's a lot of details we need to discuss. What do you think? Any question at this point?
No, sir.
All right. And that's the rule right here. need to enable the what we call hot stand router HSRP, which is this is the Cisco protocol. It's developed by Cisco long time ago. So HSRP is used a group of router for selecting active. Okay, so we have different version of HSRP. We have version 1 and version 2. Version 1 support from up to 255 routers to be on to participate in the group. On version 2, we have 1024. Okay. Of course, you have virtual router redundancy protocol version 2, which is this is non-proprietary election protocol that dynamically assign responsibility. So there's not Cisco issues here. So we have a different standard. Now, Cisco came up with this, we call Gateway Load Balancing Protocol, which is GLBP. There's a lot of different names, and I cannot say them fast enough. When you say FHRP, HSRP, VRRP, GLBP, that's a lot of different acronyms, okay? And Cisco, they came up with this idea. They said, okay, since we have 2 links and we have 2 gateways, why we need to put one in standby? Why we cannot make it open and forward traffic to it if we can? And that's why they created the gateway load balancing protocol, so we can send traffic both ways. But still, we're gonna have one router in charge, one router the boss. Okay, so the first packet the router receive. Okay, the second packet is gonna go tell them, okay, go the other way. So one goes this way, one goes the other way. One packet goes this way, one packet goes the other way. Now, if one of the router goes down, then one router will take the responsibility and forward all the packets in one way. So that's the idea of GLBP, okay, which is made by Cisco. It's the same idea like an STP. Remember in STP, we have one link is blocked. So Cisco said, okay, since we have a link in there, why we cannot use it for different VLANs? And probably the same concept over here they did with the GLBP. So that's the HSRP, and that's what we need to configure your router with that. Okay, so that's the idea. Now, we already talked about active router and standby router, and also because this one has the highest address and this one has the lowest address. So somebody said, well, I want to make router 1 to be the active one all the time. Okay. Can I do that? The answer is yes. How you do that? Well, I increase the priority. So if I increase the highest, the router has the highest priority, that's the router is going to be the active one. You notice here we have priority 150. Over here we have the priority 100, which is the default one. So therefore, if I configure it that way, so this is going to be the active one. Now, question: what gateway or what is the default gateway address for all these clients right here? If this is the active router, this is the standby router, and this is the virtual router. So what is the gateway address, or what should I put as a gateway for all these machines right here? Somebody give me the address.
The virtual.
So we have to put correct virtual. 172.16.1, not 2, not 3. That one is that's the virtual IP address. Okay. And also the virtual IP address is associated with this MAC address. And you can tell from this octet here, 0707, not octet, this is hextet, OC07. And I can tell they still using version 1 from this address right here. Now, if you're using version 2, you can see 09 instead of 07. That's how I see between them. Know the difference between version 1 and version 2. So this is what they're talking about here. To configure the router to be active router, use the standby priority interface command, and the range of the HSP priority is 0 to 255. Now, if we put 0, if you put the priority 0, that means that router will never be an active router. It's always going to be on standby. Okay. Any other questions? Now, they mentioned something called preempt. What does that mean? A preempt is a configuration. You do it on this one here. For example, you say, well, and most of the time, especially in here, if you have, for example, a PCA, the PCA is connected to this router, or your home, for example. You'll never know. As long as you have a link over here, from here to the gateway, you're okay. You're not going to tell if you have access to the internet or not. Now, what happens if this link goes down? Or this? Or any of the interfaces? So that's why you configure something we'll call preempt. Preempt means is like a trigger. So basically you configure and say, well, if something happened to this interface, I need to know. That's how you configure the preemption. You trigger some kind of election, who's going to be the active, who's going to be the passive. And the way it works, if this goes down or this goes down, the priority value is going to decrement by whatever value you put. By default, I think on the packet tracer is decremented by 10. So you're going to subtract from 150 at 10. Then if this is down or this is down, it's going to be, this value is going to be 140 instead of 150. So always whenever you configure the priority, don't make it high like this 150, especially on the lab. Because if you decrement by 10, still this has highest priority. Still this is going to be elected as an active one. So you put, for example, 105 on this one here. So if this link goes down, you decrement it by 10, then this is 95, this is 100. So therefore we go that way. You get the idea? So, I mean, tomorrow after the test, which is Monday, we're going to do some configuration on this one. So you'll be okay. So with the preemption disabled, the router that boots up first will become the active router if there are no other routers online during the election process, which is true. So everybody think is the active router before you configure it. Once you configure it, then they exchange information between the two. And say, oh, you have the highest priority, then you will be this is going to be active on, this is going to be standby. Okay, so if you don't have a question, I'm going to stop at this point. And for the test tomorrow, as usual, you're going to have some kind of hands-on. You're going to create the DHCP server for 2 LANs, and also you're going to configure a router as the DHCP server for a different LAN. and you need to make the layers talk to each other. Okay? I think the question at this point. The test start at 9:25. And as usual, I upload the topology for the skill test on the files folder. And also, whenever you do a packet tracer, you need to put your name on the profile, like we talked about before. I don't have to repeat it every time. So when you go over here, and instead of put guest, you put your name, you put your email, and you say okay, and you send your file. Okay, again, you don't have to zip this file. Don't zip it. Just upload it to the appropriate assignment. Okay. Any question? No question? Man. Guys don't ask any question. That means that you good? You know everything? I guess.
No. Don't know everything.
Not enough to feel confident.
Well, good. I'm glad. Some of y'all agree, but some of y'all, I mean, few people, I don't know, they don't ask any question. Even they're not on the call today. So, and sometimes I worry about them. What else? Okay, so if you have enough, we'll do some more on Monday on this one here. It looks like if we finish the chapter on Monday or Tuesday, so at the most we'll have a test on this particular chapter on Wednesday. Oh no. This is like how many chapter?
Well, this test is 7 through 9.
I'm sorry, 7 through 9?
Yeah.
Oh, so you don't have test on tomorrow. Why
Okay.
I'm thinking, yeah. Why I'm thinking you have a test?
I don't
7
know.
through 9?
Yes, sir.
Oh. I'm get used to the other Cisco classes because every chapter we have tests. So that's why. Oh, okay.
Okay.
Yeah, no problem.
Mrs. Charif,
Yes.
we got a email from Scott saying that we'd be returning to classes on Wednesday. Is that still your plan, or what's up? Do you know anything more about
Returning
that?
on Wednesday.
Mm-hmm. It's in Canvas.
Man, mostly everything's still shut down, and they still doing like whatever phase 2 or whatever. I don't.
Yeah, I'd also like to
I'm not
make this
going to school.
mandatory because I would like to not go to class as well.
Same here. I'm not going to be there.
I live with my older mother. I can't risk getting her sick. And I know everyone's not going to be wearing masks because people don't want to. So
And then you're not going to sanitize everything, and that's a lot of people who are just
exactly.
Right.
a lot of people. It feels like up right now. That's way too early.
Yes, sir. I agree.
I mean, if you guys comfortable what we're doing, that's fine with me. If Scott wants to do his class, this is up to him. What time is your class with him?
10:50 to 12, I think.
I see. But it's up to y'all. If you decide to go to do the lab, let me know because it's gonna be from 8 to. I was thinking only for the server lab, but if you're comfortable with it, that's fine. You don't have to go.
I'm going to
That's what we're saying, Mr.
email Scott to let him know that I'm not personally comfortable returning to class.
Yeah, just tell them that. Yeah, just So
I played
I'm sure you
school
can do
today.
the same thing remotely because especially on Linux, because you can install a virtual box and you can install Linux in it. And you
Which
can
is what
practice.
we've all done already. But
Yeah.
Just upload the labs. I mean, we do everything from home already. We don't even.
Yeah,
He
if that's
hasn't
the case,
hosted any like classrooms or anything.
yeah, if that's the case, you don't have to. Be honest with you, I mean, we're doing great on the Cisco side, but on the server, that's the only thing I worry about because we're not getting a lot of hands-on. But if you do the labs, that's you don't have to go. I agree with you. I'm not comfortable to go myself too. So um now I'm not
But
comfortable
the question we have,
health-wise. I'm sorry.
I said, the thing is, though, if most of us aren't comfortable going, what's the point of even saying that we have to go?
Wouldn't have to go. So
Because I don't know if Scott's gonna like
Yeah.
listen to any of us, so I don't
well, I
know.
mean, if you guys
force a quiz of some sort on us.
now if you guys get to all of you all together to say, okay, look, we're doing well in the class and we can do the exercises we need to do. So it's no sense to go to the classes. I think that
If the majority don't show up, there's no way he's gonna keep trying to host
yeah,
it.
yeah, I agree with you. Just send them an email, all of y'all, and
Communicate
tell them,
first.
look.
And if he still doesn't give us pushback, then we just don't go, you know.
Or what you can
I
do,
agree.
you go to class one day and all of y'all and beat him up, and so you don't have to go again.
That's a good plan. I like
Hey,
that
all right,
one.
Charif, yeah.
There we go.
He don't want no
Oh, man.
static.
Just kidding, okay.
I know.
Oh, no, I'm recording.
Man, no problem.
Yeah, we'll take that up.
Well, that's fine. If you don't feel like it, that's fine. It's up to you guys. I mean, the reason why we need to be
Okay.
there is because some people, like, if they feel like they're not doing well in the virtual environment. But it looks like on your grades, they doing majority of y'all did well. So I didn't see the point. And actually, I mean, with the method with delivering the recording, I think it's way better because you can see the material over and over and over, especially from the lab perspective.
Well, you're the only one that's doing it. He's not doing it.
Not doing a thing. I mean, he just uploads assignments, and that's pretty much it.
Yeah, we've been self-teaching ourselves the entire Linux class, so
Oh, you're not doing WebEx?
No.
he doesn't do any meetings or
No.
anything. He just
No.
basically gives us the chapter to read. We read it, we do the labs, and then we do the test and everything from home. So he just
Oh,
uploads all his work, and we have to just teach everything to ourselves because he doesn't actually do any teaching for the online stuff.
oh,
At all.
oh, we need to tell him that. Let's see. Okay. Um, well, yeah, I mean, how you feel what we're doing here? Anything you think I need to improve on the quality and stuff like here?
I like these. I mean, this works for me.
It does because I mean we
Yeah.
actually go back and we read and you're connecting the dots between what we're reading and what you're teaching, so where we understand. But then we go to the other class and we feel like that. So we get it. But we're having to rely on each other to learn the material.
Yeah.
Okay.
And as for any type of, making sure that
That's
we
what
do
I
it
like.
correctly,
I
it's
like to
not there.
do. Yeah, the main thing is to keep communication. Like if you have a topic you don't understand, so send me an email, say, well, I don't understand this specific topic or the so you always keep communication. So I'll be glad to help you guys out. And even if we need a extra session on Saturdays, I'm willing to help you out with that too. So
Awesome.
but the main thing is to keep communication, because I don't know basically what you know, what you don't know. That's why I try to ask questions, and sometimes there's nobody answers. Like, oh, maybe they know it, maybe they don't. So that's why we need the feedback.
Yeah.
Yeah, I like the packet tracer stuff here helps a lot. And you know, like with Linux,
Yeah.
like he sends us anything like hands-on related or anything, you know, he just gives us the stuff to do, which I mean, we have the labs to do ourselves, but it's, I don't know, like any WebEx meetings would have been helpful, but it's just kind of like a whole semester where it's like, here's the book, you know, read it and teach yourself the entire thing.
Yeah.
It doesn't actually provide any, I guess, like help in that aspect.
That's
Plus,
cool.
his like quiz hints and like his study guides are also always so vague, so doesn't really help guide us in the right direction, anyways.
Lord.
I can try to tell them to start doing WebEx. Maybe that will help. At least to go through the commands, like so I guess that's maybe why when it wants, I don't know why he wants to back to lab. I will see. Anyway, for this chapter, any question about the so far what we covered? So tomorrow we're gonna do the configuration on this one here, and I'm gonna tell you how to configure it. And if we disconnect one of the link, we're gonna see how the router is gonna change from active to standby. So this is a configuration. This is gonna be hands-on lab on it. So then after we finish that chapter, so you said that's chapter 7, 8, and 9 as one test. So that will be good. So by Monday, yeah, by Tuesday, I believe. Tuesday or Wednesday, so we're gonna have a test for this modules for 7, 8, and 9. You said
Yes,
Yes, sir.
sir.
so we're gonna have 7, 8, and 9. So in the meantime, keep taking the quizzes on all these modules because that's very important, and you can take the online test, and we can have one skill test.
Oh shit, it's about to go down.
So what was on the 7? Oh, basically what I'm going to give you on this one here is going to be simple. On this, I'm going to give you something like this, and we're going to have like a server over here, and this server will support. It's like a DHCP server.
Okay.
Or I can make them separate. I can give you 2 packet tracer on one. You can figure this one and this one to make it easy. This way, if you miss in one, you don't have to penalize for both of them.
That works.
Okay.
Sounds
We'll
good.
have a nice afternoon, the rest of the day, and we'll see you tomorrow.
All right, take care, Mr. Charif.
Yes, sir.
You too. See you tomorrow.
Have a good one.
You too.